All right, here we are today in Workplace and Apprenticeship 20. We're looking at section 1.3. And this section is called Rate of Change. Okay? So we've talked before about slope, right? Remember slope 1.2. So rise divided by the run gives us the slope of a line. Well, if we think about slope, slope can represent a rate of change between point A and point B. A rate of change. So let's say, for example, right? Let's say that you can eat 5 hot dogs in 10 minutes. Okay? You could figure out how many hot dogs per minute you can eat. And that would be a rate of eating, right? Or a rate of change. So what's 5 hot dogs per 10 minutes? Let me write that down here. 5 hot dogs per 10 minutes. So what would that be if we were to divide 5 divided by 10? What would that be? 1 over 2, yeah. So 1 over 2, or half a hot dog for every minute. Now that seems a little slow, right? So for you guys, probably would be 10 hot dogs in 5 minutes, right? That's probably what it would be for you guys. 10 over 5. So 10 over 5 is 2 hot dogs per minute. That is a rate of change. So when we're talking about rate of change, we're actually talking about slope. We're talking about slope if we're graphing 2 quantities where the hot dogs, and again, this is not this example, but let's say this is hot dogs right here, okay? The number of hot dogs, and we've got 5, 10, 15, let's say, okay? And we've got minutes, right? We've got 5, 10, 15 minutes. So 15 minutes. This is time, and 15 hot dogs. So in 5 minutes, you guys do 10 hot dogs, right? So that would be the point right there. So what is the rate of change here between 0 and this point right here? Well, it's a rise of 10, and it's a run of 5. So this slope is also the rate of change, and it's the slope is 2. So let's take a look at, before we get into this right here, the formula, let's take a look at this graph right here, okay? First thing. Now, you guys don't have this on your paper just right now because you just handed in your assignment, but if we look up here like this, do you see how there's a number of points that are in a row here, that are in a line, okay? So this represents some kind of linear relation. It's a straight line. Now, how do we find the rate of change? So what's happening is the 2 variables, the x here and the y, they're both changing at the same time, aren't they? When x goes up by 1, y goes up by 1. If x goes up by 2, y goes up by 2. You guys see that? So the rate of change with the x and y would be equal to the slope. Okay? And so this one says this: if a line on a graph rises from left to right, the slope is positive. Okay, well let's think about this. If we start at 0, what's the rise here between this point and this point? The rise is, it's 1, and the run
1
is 1. So look at that. The rise divided by the run is 1. That's a positive number, isn't it? 1 over 1 is positive 1. So if the line on the graph goes up from left to right, the same way you read, if it goes up, that's a positive slope. Okay? That means we have a positive run and a positive rise. Okay. Any questions about that so far? Okay, let's talk about this right here, because this looks kind of scary, doesn't it? That is like a formula that looks pretty scary, so let's just talk about that for a second. This is actually the equation that you would use to calculate slope for any 2 points on the graph, on a straight line graph, okay? Let me just break this down for you here. M is actually a symbol for slope. Don't ask me why. I'm actually, offhand, I don't know why. There probably is a reason. I'll have to look that up. But there's lots of S's in math already, so I kind of stay away from that. There would be a reason for the M being slope, but I don't know it just offhand. Now, the formula for this is this right here. Now, this is a bit funny, but let me just break it down for you. Notice we have x's and y's here, okay? The y-axis is this vertical axis. Everyone see that? See this vertical axis right here? That's the y-axis. So that's, look at how there's two y's up here. The x values are in the denominator here, and that's the horizontal axis. Everyone see that? Okay. So the rise would be the change in y values. You see? That's the rise. And the run is the change in x values. That's the run. So if I really wanted to find out, let's say this point right here is 0, 0, right? It's 0, 0. This point over here is what? What's the coordinate for this point? Right. Don't say it out loud. Just whisper it. Okay? Yeah, 4, 4, right? Okay. So I know that the rise between this point and this point right here is what? 4 units. Okay? That's good. Now, there's a 4 there, isn't there? The y value is 4. The run is 4 units to the right to get to this point, and there's that. Now notice this. This actually is 4, the rise is 4 minus 0. It's this number minus this number. And the run is this number minus this number. Okay, that's the run. Let's do something. Let me show you how this works for other points as well, because 0, 0 is kind of a little unfair. So we still have 4, 4. What about if we took a look at this point right here? This point is 2, 2. Everyone see that? Okay. Now, if you wanted to calculate the slope between point A here, which is 2, 2, and point B, which is 4, 4, then you could use this special equation right here, the slope formula. And let me show you how that works. Okay. So this right here, let's say this 2, 2, this would be like x and y, right? That's x and y coordinate. So if we consider the first point to be x1, y1, then the next point would be x2 and y2. Okay, so any 2 points, x and y. Look what I have in the formula. How do I calculate what would be the rise? Well, I take the second y value point. See it? It's right here. That's a 4. So my rise over run is going to be y2, 4, minus y1. And what's the y1? Well, for this point it is 2. Okay? So that's y2 minus y1. The run is going to be the difference between the x values. So this x value and this x value. What's the difference there? Well, it's 4 minus 2. That's the difference. Or x2 minus x1. So this is going to be 2 over 2, and we see that that simplifies to 1. Same thing we got before. Okay? How many of you have seen this slope formula before, or remember it? Okay, if you've taken Foundations 10, right, you would have seen this one. Okay? All right. So we'll get some more practice with that here, okay? Let me talk about this case though first. Like if we have a line that goes down from left to right, that's going to be sort of the opposite kind of slope as going up. So if this is positive, this one's going to be what?
Negative.
It is. It's going to be negative. So it's a negative slope. And we see that right here. Negative slope. Now, why is that? Or let's actually calculate the actual slope here. Can we? Let's see. 1, 2, 3, 4, 5, 6, 7. Okay, so that's 7. Okay, and this is 4. You see that? So what's the coordinate for this point right here?
4, 7.
Well, we have a 4 and a
4.
7, but we always put the x coordinate first, right? So from 0, 0, we go over 7 units, and then up 4. So the point is 7, 4. Everyone see that? Okay, that's pretty important to understand. Pretty important to know. So what would the coordinates of this point be then?
1 and 7.
So we go over 1 to get there, and we go up to 5, 6, 7. Very good. 1, 7. Everyone see how those are the coordinates for those 2 points? You okay with that? Okay. All right, so let's find the slope. Let's find the slope. This is actually going to be pretty easy if we use the formula. And this would be something you probably want to memorize, guys, okay? y2 minus y1 over, or divided by, x2 minus x1. And that simply says, now this is going to feel weird because I'm going to take the smaller one first, right? So this is going to be 4 minus 7. Okay, 4 minus 7. And this one's going to be 7 minus what? 1. So y2 minus y1 divided by x2 minus x1. So what's the actual slope here? Well, if I simplify that, 4 minus 7 is negative 3. Please be aware of the negative signs, okay? It's not just 3, it's actually negative 3. And 7 minus 1 is positive 6. So the slope here is negative 1/2 if we simplify that. So see, this is a negative slope. It goes down from left to right. And now we've proven that by using our new slope formula. Okay? What do you say? So far, are we getting this? Any questions? Okay. All right. On your paper now, do you have this in your paper? Do you have this yet? Are we on second page yet?
Yes.
Okay. So I want you to draw this on your paper right now. I want you to draw a point right here.
Oh, we don't have this graph.
And you don't have this graph? Oh, okay. Well, that's what I was wondering. You don't have this graph?
No, next, I have that graph.
But it's on the other paper that you don't have? Okay. Okay, forget about that then. Let's see. Do you have, what else do I have on here? Do you have those two?
Yes, I have those.
Okay. All right. I tell you what. Let's figure out the slope of these two. Okay. So right now we have one point that's here, and the other point is clearly 0, 0. So we have 0, 0, and we have, what's this coordinate here?
4, 3.
4, 3. Very good. Okay. So what is the slope? What's the slope of this?
4 over 3.
4 over 3?
Hold up.
So remember, we're doing rise first. So what's the rise? It's 3.
Oh.
See, the rise is 3? And what's the run? 1, 2, 3.
I had it jiggled up there.
Okay. All right. So the slope is 3/4. Now, let's use our new slope formula and see if we get it right. So y2 minus y1, write this out again, over x2 minus x1. Okay. Need to memorize that. Very, very important. So let's just fill this out. What is y2? Which value is y2 here? 3. Minus, what's y1? 0. What is x2? 4. And x1?
0.
So that's 3 over 4. See that? So if you look at the graph and you count rise over run, and if you subtract y2 minus y1 divided by x2 minus x1, you should get the same value. Okay, take a moment and see if you, without looking at the solutions on the next page, see if you can figure out the slope of this line. Okay? And I want you to use this new slope formula there to figure that out. Take a minute to do that. Okay, so this is what you should have got for B. And let's just go over that real quick. So this is, remember, I usually take the first point as being the one that's on the farthest left. Okay? So this is going to be, the coordinates are x1, comma, y1. The second point is going to be the one that's on the right. So x2, comma, y2. Does that make sense? You get that? So we've got y2 is 10 minus y1 is 5. 10 minus 5 right here. Then we've got x2, which is 6, minus x1, which is 3. 5 by 6 minus 3. 10 minus 5 is 5. 6 minus 3 is 3. That can't be simplified anymore, so that's your slope, a positive 5/3. Okay, any questions about that? All right. Okay, Now take a moment to do this one. Do C. And just kind of, just jot down your work just real quick, kind of right beside it there. All right, so again, first thing you want to do is identify the points, okay? And you can use your new slope function here. You should have a value of negative 5 over 9. Now, again, if we were counting from the graph, you could just go from the far left point, you could go, how far up or down do I have to go? What's my rise? 1, 2, 3, 4, 5 units down, that's negative 5. And then what's my run? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a positive 9. So rise over run is negative 5 over 9. And of course, this is how you would use your formula. So the nice thing about this is, guys, is that you don't need a graph to calculate slope. You don't need, because from a graph you could count rise over run, right? But you don't need a graph for with using this, and I'll just show you real quickly here. You can calculate the slope, okay? So write this question down. Calculate slope of line containing points A, which would be, let's say, 2, 6, and B, which would be, let's say, negative 4, 8. Okay, so here's another example. Okay, so this is what I'm saying. When you have a question like this, you don't need to graph those first. You can just use the formula. And you know what? It doesn't matter actually which point is 1 and which is 2. Doesn't matter. Nope, doesn't matter at all. You'll get the exact same answer. So I'm going to make this one number 1 and this one number 2. So this is going to be x1, y1, and x2, y2. So without graphing it, I can quickly find the slope. So we're going to go 8 minus 6 is on top. See that? And I'm going to go negative 4 minus 2 on the bottom. As long as you keep the second point for both values, doesn't matter which one's first, which one's second. So you see how I went 8 minus 6, and then I went back to this one, negative 4 minus 2. So 8 minus 6 is 2, and negative 4 minus 2 would be negative 6. So this would be negative 1/3, looks like. Yep.
So the second of the two doesn't, like, it has to be the first one?
The second of the two has to be the first one. What was that? Sorry, say it again.
And 6 has
Yeah.
to be on the top.
Yes. 8 minus 6 has to be on the top because these are the change in y values, which represents the rise. Remember, rise is always on top for slope. Yeah. Okay. Good question. Anybody else have a question? Okay. All right. So I just want to go over this question because I saw this was in your practice problems there, and we just want to talk about this because this could be kind of confusing. But 2 lines here. One is totally flat, horizontal, and one is totally vertical. Okay? So with the first line, the line 1 here, what's the slope? Well, the slope would be from this point to this point. What's the rise? How far up or down do you have to go from the first point to get to the same level as the second point?
0.
Yeah, the rise is actually 0. So watch this. 0 over,
6.
does this even matter? 2 to 9. Looks like maybe 7. So what's 0 divided by 7? Should be pretty easy. Oh, is it 6? So let's see. 1, 2, 3, 4, 5, 6, 7. It's not 6. 7.
All talking about the rise.
The rise is 0. The rise, see, we don't go up or down at all from this point to get to the level of this point.
Yeah.
So 0 divided by 7 is
0.
0, okay? That's totally right. So the slope of a horizontal line is always 0. You might want to just jot that down somewhere in your notes or whatever. I'll put that down here. The slope of a horizontal line is always 0. Okay, so horizontal line. Now the vertical line, let's take a look at that one now. So line number 2 Okay, slope is, remember, rise over run. So between this point and this point, what's the rise?
7.
7, are you sure?
Positive.
Okay, so the rise is 7. What is the run? So that means how far right or left would I have to go to get to the same vertical plane as the second point?
0.
0, okay. So this is 0, 2 then, I guess, or what? 7 divided by 0, what's that?
7?
Is it 7? You think it's 7?
Is anything divided by 0 is 0?
Anything divided by 0 is 0?
I mean, it can't anything divide by 0.
You can't divide by 0. That's actually true. You can't divide by 0.
So what is it then?
Well, it's not 0 and it's not 7.
Oh, what is it?
Nothing.
But
It's
it
nothing?
has to be
What do you think it is?
I honestly personally think it's 0.
You think it's 0.
That's
There's a negative or something.
Negative? Negative 0?
No, not negative zero.
Okay. Syntax error. Okay, it's syntax error. Yeah. So dividing by 0 is a problem in math. This generally is. Like if you have two things and you divide by 0, it's kind of like how many would be in each group if you had 0 groups, or to divide it into 0 groups, how many would be in each group?
0.
Nothing.
No, but you're taking 2 and you're basically making it disappear.
0 people.
Use a hot dog example again.
You have 0.
Okay, you have one hot dog. How do you divide it in? Okay, you can divide it into 2 groups, right? You could divide it into 1 group. You could even divide it into 0.1 groups. But you can't divide it into 0 groups, because that would mean your one hot dog would have to completely disappear. Which you can eat it, but it doesn't disappear. Okay, okay, we won't talk too much more about that. But on your calculator, if you go 7 divided by 0, it's an error. The error is you can't divide by 0. Okay? Because you can't divide it into 0 groups. Okay. So this is we're going to say undefined. Okay? That's what we're going to call the slope of a vertical line. The slope of a vertical line is undefined. That's what we're going to call it. Okay? And let's do that. Okay? The slope of a vertical line is undefined. I'll make them both capital there. Okay. Got it? Okay. One more type of question before I let you practice this stuff, okay? I'm going to practice this stuff here once I do this example. So this is the final example here, sort of for part 1 here. So draw a line that passes through A and has a slope of 2, and another line that has a slope of -4/3. Okay. So what we need to do is we need to draw a line through A that has this slope. So watch this, 2. That's a positive slope, right? So we know it's going to go up from left to right. But how far does it, like how steep is it? Is it like this, like this? Is it like this, almost vertical? What is it? Well, remember, a slope of 2 is rise over run, right? So the number 2, what's in the denominator there if I actually, what's the run for a whole number like this? It would be 1, yes. So 2 over 1. So the rise, so what you do is you start at point A, and you go a rise of 2, and a run of 1, and you put another point down. So we go from here, we go rise of 1, rise of 2, and then a run of +1. There's your next point. You can do that indefinitely. You can keep going. 1, 2, over 1, and so on. And you can actually go down 2 and left 1. Because you see, you could do this. You see? That's the same as +2. Well, a negative divided by a negative is a positive. So you see how you could put points down here too. 1, 2, 1. So here you go. That's how you draw a line with the slope of 2 going through A. Now we're going to do the same thing for this slope of -4/3. So remember, rise over run is -4/3. It doesn't really matter where that negative is, on which number, as long as it's just on one of the numbers. So from A, we're going to go, I'll do this in red, I guess. So a rise of negative 4. What does a rise of negative 4 look like?
Going down.
Going down, right. So from this point, again, we start at A, and we go 1, 2, 3, 4. A run of 3, is that left or right?
Oh, that's right.
Right. So 1, 2, 3. See that? So there you go. There's your next point. And so you, all you need is 2 points really to draw a line. So this is really tough for me freehand on this tablet. But anyways, that's what your line would look like. Okay. Yeah, thanks. Okay.
The thickness is a little off.
The thickness is a bit off.
Yeah.
Thanks a lot. Okay, guys get that? Okay, what if I put C here? What would it look like if I put slope of 0?
Just flat.
What's that? It's a what?
Flat.
It's a flat?
It's a
Flat line? Is it flat or is it vertical? Which one?
Vertical is undefined.
A vertical has an undefined slope,
To be argued to be 0.
which could be argued to be 0. Well, this slope and this slope are not the same.
Why if you just switch?
So this can't be 0 and this 0, right?
Yeah.
Right?
I'm just
So that's why dividing by 0, that's one of the reasons why dividing by 0 is not 0. Because it's very different when you put it into the slope perspective.
I'm on my new life, but don't divide. I'm going to be the first person to divide 0.
You're going to be the first person to divide 0. Okay, good. Good for you. That would be great. You'd probably win some kind of cash reward for that, I'm sure. Not from me, but maybe from somebody. Okay, so what I want you guys to do now is to build your skills.
So we just have one question then.
You don't have one question. You have 1, you have 2,
We just did.
you
two,
have
we just did
3,
You did those.
you have 3.
You just did 2 of those.
like that.
No, I didn't do 2 of them.
Yeah, I did.
No,
Well,
these
they're
are different.
Exactly the same.
No.
No, they're not exactly the same. Sorry.
One of them was
Yeah,
exactly
no,
the
they're
same.
the exact same.
Well, this one's not, so the numbers.
Okay, why don't you start at 1 and just keep going? And if I've done something, you have to rewrite the answer. So 3 is similar but not the same. Okay. So go ahead and take some time to work on those 3 questions. Go.